All right, so in this video here, we're going to present some precipitate reactions, get you more familiar with precipitation reactions and what occurs in precipitation reactions. On page 147 in our book, we have the solubility rules, table 4.1, and we see the solubility rules explaining the different kinds of solubility products or the materials that will not be soluble in aqueous solutions. So we talk a lot about solubility and precipitation reactions, and we're going to show you some of the precipitation reactions. You can have the rules nearby and look at them. We start off with 3 vials of sodium hydroxide. These 3 vials of sodium hydroxide, to the first one we add copper sulfate. And as we see in the solubility rules, all metal oxides or metal hydroxides are insoluble except for group 1A compounds. So we see the copper hydroxide forms when we add copper sulfate to the sodium hydroxide. In the second one we have sodium hydroxide and we add iron chloride, and we see the iron hydroxide forming a precipitate. The precipitate is identifiable usually because you can't see through it. Sometimes you might form a gelatinous, more gel-like precipitate, but in these cases you see clearly the precipitate that's forming. All right, in the last vial of sodium hydroxide we add nickel chloride, and we have the precipitation of the nickel hydroxide. So the nickel hydroxide is kind of a lightish green color there you see. Okay, so this is our copper hydroxide, our iron hydroxide, and our nickel hydroxide precipitates forming. In our next vials here we have 3 solutions of sodium carbonate. Again, sodium carbonate is soluble because even though carbonate is generally insoluble with metals, sodium is a group 1A metal. So when we add copper sulfate to the sodium carbonate, we see that the copper carbonate forms, a precipitate forms, because again, according to the solubility rules, the carbonates are generally insoluble. So to our second solution of sodium carbonate we add iron chloride, and the result is iron carbonate, that is the precipitate there. So we have iron carbonate forming when we mix the iron chloride with the sodium carbonate. To our third vial of sodium carbonate we add nickel chloride. The result is nickel carbonate. Again, insoluble, and the colors of these precipitates look very similar to those of the hydroxide precipitates. So we have 3 precipitates formed with the carbonate ion. Now we have 5 solutions here of sodium phosphate. The phosphate ion is generally insoluble, so when we add our copper sulfate, then the copper sulfate interacts with the sodium phosphate to result in copper phosphate insoluble product, right? So the copper phosphate is what's formed there. When we add the iron chloride to the sodium phosphate solution, the result is the iron phosphate forming. Again, iron phosphates. And you can look in your periodic or your solubility rules that indicate that phosphates are insoluble except with group 1As and ammonia, right? So the third one is our nickel, and we see that the nickel with the sodium phosphate, the nickel chloride forms a nickel phosphate. The fourth one here is silver nitrate. Silver nitrate is soluble because nitrates are soluble, but when the silver mixes with the phosphate in the sodium phosphate, then silver phosphate precipitates out. In our last vial here we add lead nitrate. Lead nitrate is soluble, but when the lead mixes with the phosphate, lead phosphate precipitates out. Now we have 3 vials here. The first one and the third one are sodium chloride solutions, just salt water, and the middle one is potassium iodide. And we're looking at the exceptions for the halides, right? Generally, halides are soluble except for chloride when it's mixed with silver nitrate. So we just added silver nitrate to the first one there, and we got silver chloride forming. And to our second potassium iodide sample that we had there, we added silver, and we saw that there's a precipitate as well. So therefore, we're seeing that silver iodide forms a precipitate. To our last solution of sodium chloride, we're going to be adding lead nitrate because that's also one of the exceptions to the halogens. that lead in combination with halogens will form a precipitate. So that was lead chloride. Now we have 3 solutions of potassium chromate. Soluble, it's a different color, but it's still soluble. You can see through it, right? It's a yellowish color. But when we add copper sulfate, we see that the copper is not soluble with the chromate ion. All right? It's not the potassium ion, the potassium with the sulfate. Potassium sulfate is soluble, but it's the lead or the copper chromate. So we have no rules about chromate ions in our solubility rules, but this is just an example that other materials are also insoluble. Here the last one we've mixed is, or the third one there is the nickel chromate. But the nickel chromate has a degree of insolubility, but it appears like it's almost completely soluble. There's some cloudiness, but not nearly as much as the first one, which is the copper sulfate, the second one, which is the addition of iron chloride, and the third one, or the fourth one, which is the addition of lead nitrate. So we're seeing the copper chromate, the iron chromate, and the lead chromate all precipitating out.